Good day to Madam Salavati. We are from Group 5. Our group members are Tan Jing Ting, Un Wing Wai, Heng Sheng Wei, Felix Chai Fu Choi, and myself, Long Jie Hui. Today, we would like to present the operating system project regarding the process scheduling algorithm. The task given is to propose the best process scheduling algorithm according to the list of jobs given to update the process scheduler of Unima's web operating system. There are 4 process scheduling algorithms offered by Unima's web, namely first come first serve, shortest job next, shortest remaining time, and round robin. Now I would like to pass to Felix to continue the presentation.
Okay, thank you, Ms. Jie-Hui. So I would like to talk about first come first serve algorithm. Basically, the first come first out, or also known as first come first serve algorithm, is the simplest scheduling algorithm. It is actually simply queue process in the order that they arrive in the ready queue. For example, when the first job came in, it will follow by the second job 2, job 3, and the job 4, and so on. It is most commonly used algorithm because it is the easiest and the simplest algorithm. However, it has a serious drawback where it has a long turnaround and waiting times. So next. Based on our coding that we have done, it is discovered that the average waiting time for the first come first serve algorithm is about 158,000 for the average waiting time and 169,000 for the average turnaround times. So it is quite taking quite long compared to the other algorithm. So yeah, and I would like to pass my mic to Miss Tan Jing Ting, where she will explain about the SJN algorithm. Thank you.
Thank you, Mr. Felix. Now I would like to talk about shortest job next. SJN is a non-preemptive scheduling algorithm that based on length of CPU cycle time of each job. When CPU is available, it is assigned to the smallest next CPU burst. In non-preemptive scheduling, once the CPU cycle is allocated to process holds it in ready state until it reaches a waiting or terminated. At first, jobs are arrived at hold state and are placed in ready state by job scheduler. Job scheduler places the job 1 into running state to run the process with CPU and I/O instruction. After starting based on shortest burst time, job 1 is processed. Next, incoming job will be compared the length of CPU cycle of each in order to decide which job is to be run next. Next, the pseudocode is displayed to evaluate SJN scheduling algorithms. The total turnaround time, total waiting time, average turnaround time, and average waiting time is calculated. That's all from me, and now I would like to pass to Mr. Heng Sheng Wei.
Okay, thank you, the previous presenter, Ms. Tan Jing Ting. So I'm the next presenter. Mr. Heng Sheng Wei is going to present about the shortest remaining time SRT. So SRT is the primitive version of SJF scheduling. So these algorithms require advanced concept and knowledge of CPU times required to process the job in the interactive system, and hence cannot be implemented there. But in a batch of system where it is desirable to give preference to short jobs, SRT algorithm is used. In SRT, the execution of the process can be stopped after a certain amount of time. At the arrival of every process, the short-term scheduler schedules the process with the least remaining burst time among the list of available process and the running process. So once all the process are available in the ready quick, no preemption will be done and the algorithm will act as SJF scheduling. The context of the process is saved in the process control block, which is PCB, when the process is removed from the execution and the next process is scheduled. This PCB is accessed on the next execution of this process. This is known as a context switch change. Of course, the shortest remaining time also bring the advantage and disadvantage. So what is the advantage? The advantage is SRT algorithm makes the processing of the job faster than SJN algorithm, given its overhead charge are not counted. The disadvantage is the context switch is done a lot of time in SRT and then in SJN and consumes PCPU available times for processing. So this adds up to its processing time and diminish its disadvantage of fast processing. So this is the coding for the shortest remaining times. So we can see the average or the every average turnaround time and the waiting times. We can just ignore it, but we already total up the average turnaround time is the 170351 and the average waiting time is 159320. So the number of interrupt incurred is 31. So that's all for my presentation. So I would like to pass to Mr. Un Veng Wai.
Okay, thank you for Hing Hing Wai. Now I'm going to telling about the round robin scheduling. Round robin scheduling is a preemptive scheduling algorithm. It is important to include the context switching, which since it is the preemptive scheduling, always get the interrupt. So context switching, which help to save the process burst time. Secondly, it is the most commonly used algorithm in CPU scheduling. In concept, each process is assigned with a fixed time interval to execute. It's called time quantum or time slice. From our project, we are assume time quantum as 10. In the round robin, the process get preempted if it is executed in the given time period and the rest of the process executed across. Round robin is a session-free CPU scheduling algorithm as all the processes get fair sharing of CPU. Round robin is also a preemptive version for the first come first serve scheduling. It involves the first come first serve set. So in the round robin algorithm, each process is cyclically executed. Next slide. Now the picture showing in the result we get from the RR scheduling algorithm. The total number of jobs involved in the is 13. The time set as 10. But in our algorithm, we only code for counting total burst time for each job and does not include the IO burst time. The number of interrupt does not show in the result, but in general, it should be happen in the job list. From the result, we get to know the average turnaround time is 156110 and the average waiting time is 150588. That's all from me. Now I will pass the mic to Miss Leong.
Thank you, Mr. Un. Next, the graph shows the average turnaround time. The RST has the largest turnaround time, then come to first come first serve, shortest job next, and the smallest is round robin. Whereas for average waiting time, RST also has the largest waiting time. Next, the second large is F first come first serve and come to shortest job next, and lastly to round robin. In conclusion, we recommended shortest job next process scheduling algorithm as the best process, since it has the less average turnaround time and average waiting time compared to first come first serve and shortest remaining time. Although our round robin is the least, the average turnaround time of shortest job next is 170351 and average waiting time is 159320. We are not recommended round robin because the algorithm did not calculate the input-output and its interaction. So the result of round robin are not suitable for comparing with other process scheduling algorithms. That's all from us. Thank you.